So now I'm really excited. We have the data science working group to speaking. So I guess Rocio will go first, but then I don't know if we're doing full transition or whatever to go to then Jude and Sanat to speak after this. But okay, again, right around the same time Brigade Hub started in like late January, this data science working group, this group of data scientists came to the brigade like, we want to do data science, we want to solve your problems. And then that quickly started to, how do we all work together to solve problems? And then it just turned into general awesomeness. And you're gonna like totally be like wowed by the amazing awesomeness that this great group of people is doing for projects outside of the brigade, inside the brigade, their own projects, and just such a resource to any brigade project that has questions about how to better use data. So please put your hands together for Rocio.
Thank you, Hi. All right, so I'm gonna talk about what several members of us did a few weeks ago. We entered a hackathon called BayesHack, which is held by Bayes Impact. And the purpose of the hackathon was to try to leverage data and data science into solving issues and problems faced by several departments in the government. And we decided to try to help out the Department of Transportation with a major problem that they are facing. And it has to do with the prevention of hazmat accidents before they happen, and how we can use data and data science to kind of solve this problem. So this is a very major issue. How many of you have been in a traffic jam because of an accident due to hazardous materials? So as you know, it's a very common occurrence. In fact, there's over 17,000 incidences in the country in 2015, about 47 a day. And as you can imagine, they're not just regular crashes, they're quite dangerous. They lead to a lot of fatalities, and it's very costly for local governments and to deal with this. And currently, most of the responses to this problem is reactive. It's reacting to the accidents themselves. All right, so our solution was to try to use data to build a few prediction models that can reduce casualties due to crashes, other safety incidences, and minimize the risk due to the transportation of these hazardous materials. So we kind of scoured the web for a bunch of different data sources that could be helpful. We ended up using three these main sources. So from the Department of Transportation itself, actual number of incidences that occur in a year, I think since like 1990, and we used a bunch of data from the Bureau of Land Management for Oil and Gas Statistics, which deals with the production of these materials, and the Bureau of Labor Statistics for statistics related to employment. Yep. All right, so we were able to gather data related to several features that we think might be related to the number of incidences of hazmat accidents. So So this included number of mining employees. So this is all at the state level. This was the most granular we can get. And a number of features related to the oil and gas leasing in federal lands, including things like number of acres leased by the state, number of well bores started, number of leases in effect, and so on. And we were trying to determine how these factors may influence the number of hazmat incidences at the state level. So this is kind of an overview of the tools and our process for developing the project. So we used R and Python to do a bit of the data wrangling and cleaning required, and used those tools also to build and test different models to see what would be the most effective in predicting hazmat. And we found that a random forest model, so it's a very common model used by data scientists. It's based on a decision tree. Was able to predict with fairly high accuracy the number of hazmat incidences using the features that I mentioned earlier. And another thing that we built was a model for anomaly detection, looking at temporal patterns in accidents and fatalities over the years among the different states. And so we used this to kind of build a series of deliverables at the end of the outlining our results of the models and the testing, and that's being posted in GitHub using Markdown, and also built a prototype of a web tool that can be used by officials or administrators involved in decision making regarding these incidences. Okay, so if you click this one, this is kind of quick demo. Oh, no, the second link, sorry. So here's a map to kind of outlining the most red color is the highest number of incidences. I'll just quickly demo. So these are two of the features that we found to be predictive. So if you slide it around, you can kind of see how each of the numbers for some number of producing acres and number of employees are impacting the prediction of the number of accidents that would occur at a particular state. Okay, you go back. So next step is to improve the predictive model. There's definitely a lot of traits that could be explaining variances in accidents that we're not aware of, and continue to work with the Department of Transportation on the project. Thank you. If you're interested, this is the GitHub repo if you want to look at our project, or you can talk to any of us after. So there were different prompts introduced by the different departments, and we were finalists for the Department of Transportation prompt.